anatomically modern human beings have been on this planet for roughly 200,000 years. And even though that's a small fraction of the amount of time the Earth has been around, which is over 4 billion years, on a human scale, it's an incredibly long amount of time. Just to put it in perspective, if this is present time, if you wanted to put when was the Roman Empire, well, if you're talking about 2,000 years ago, it would show up on our timeline right about there. If you wanted to talk about when the pyramids were constructed, it would be right about there. You can hardly see the time difference between now and several thousand years ago. If you want to see how long we've had writing, about 5,000 years is our current best estimate. Once again, it barely shows up on this timeline. How long have we had agriculture? Well, 10 to 15,000 years. Once again, it's a small fraction of this. Another way to think about it, think about all of our ancestors, the various generations that have passed since the first emergence of the first appearance of anatomically modern human beings. This is over 6,000 or 7,000 generations into the past. Think about all of the stories that must have happened. A lot of simple things. It might be a founding of a village, a killing of an animal, a very simple courtship, a tenderness between a mother and their child. And think about the big things, the wars, the battles, the natural disasters. It's hard for us to imagine how much has occurred even in the last 100 or 200 or 1,000 years, much less 200,000 years. But we seek to understand regardless, and that is what history is all about. And as we'll see, history is in general trying to understand the stories of our past. And if we want to get a little bit more technical, we can also think about prehistory, which is technically the things that happened before we had writing. Because writing is our main tool for history. What I have right over here, this picture, this is Egyptian hieroglyphs. And Egyptian hieroglyphs are over 5,000 years old. I could write 5,000 years before the present. But even when you have writing, it's not enough. As we'll see, not only in this video, but in many videos as we study history and world history, it's really a lot of science and a lot of detective work to make sense of what has happened. And that understanding will constantly evolve. For example, we didn't know what these hieroglyphs said until 1799 when we found the Rosetta Stone. And what was useful about the Rosetta Stone is that they had some text written in the hieroglyphs, and they had the same text then written in a Greek that we were able to understand. And that started to help unlock what these hieroglyphs said. But even once you have a sense of what they say, and even if you understand it quite well, you still have to do a lot of detective work and take everything with a grain of salt. You can imagine if there's a bunch of groups of people here, and we get the history from this group. For some reason, we're able to find what they wrote. Well, it might not be completely unbiased. They might have a negative view of this group or that group. And so you have to take it with a grain of salt. At the extreme form, they might have eliminated some of these groups, and then only they were around to say what actually happened. You also have to be skeptical because you don't know whether these stories are actual accounts or whether someone just made it up to fit a worldview. You also have to keep in mind that these stories, whether they were transmitted written or orally, they're oftentimes retransmitted from generation to generation. And especially in the oral case, but even in the written, you got to wonder what's added over each generation. You can imagine people embellishing, making the story a little bit better, or taking out things of the story that really doesn't fit in with their worldview. So even when we have the writing, and this is, once again, some images of early writing. This is the famous Sumerian cuneiform. There's a Sumerian cuneiform tablet here. Even when we have it, and obviously we have much, much more writing as we get to the more recent past, we have to be very, very, very skeptical. We know today, even if two observers observe something yesterday, something that just happened, they might have very, very different perceptions of what happened. So even if there's writing, we have to be skeptical. But things get, in some ways, even more interesting before we have writing. When we go into prehistory, you might wonder, how do we know anything about what happened if there's no written accounts? Well, that's where the science and we get even more detective work. For example, this is a Neanderthal skull. And the type of people, the scientists that will study this, you'll hear terms like anthropologist or anthropology. This is a study of present and past humans and human society. And then a subset of anthropology, which is really delving into prehistory and even history itself, is archaeology. Archaeology, which is the subset of anthropology that focuses on the past study of humans and human society, and they're mainly going to do it through remains. Now, there's other fields. You might associate the term of the field of paleontologist, paleontologist, ontology, paleontology. You might associate this with things like dinosaur bones, but their techniques are also useful for old human remains or even pre-human remains. And so it might inform archaeology and anthropology. So for example, an archaeologist might unearth this Neanderthal skull. They will use some science in order to figure out when did this skull enter into the ground. They might use a technique like radiocarbon dating, which could be used for things up to around 50,000 years old. So around that time span on our timeline. And it's based on this idea that you have this atmospheric carbon-14 that actually comes from nitrogen-14 that gets between interactions with the solar wind and these cosmic particles becomes this radioactive carbon-14. And that carbon-14, which can become part of carbon dioxide, incorporated into plants through photosynthesis, which then get eaten into animals. So while something is living, they will have a certain amount of carbon-14 in their tissue. But then once they die, they're no longer adding more carbon-14. And the carbon-14 decays into the more stable carbon-12. And so based on the ratio between the carbon-14 to the carbon-12, and it takes roughly 5,000 years, 5,730 years to be exact, for roughly half of the carbon-14 to decay into carbon-12. So based on this ratio, and I go into much more detail in other videos, you can figure out how old these things are, and you get reasonably precise within a couple of hundreds of years. If you want to go further into the past, there's things like potassium-argon dating, which is once again taking a radioactive form of potassium and using the idea that it decays into argon, and that when a volcano releases, the argon in that rock is able to go into the atmosphere, but then once it hardens, you have the decay, and so you can see how long since that volcanic eruption are we looking at. And so, for example, you can do stratigraphic techniques right over here. Stratigraphy, I have trouble saying these words, that's looking at the various layers of the Earth. And you might use some dating techniques, for example, potassium argon, to say, okay, this is a certain amount of age, that is a certain amount of age. This was volcanic rock from a volcanic eruption. And then you can look at the fossils. You could say, okay, a fossil that I found here is going to be newer than the stuff here, and it's going to be older than the stuff here. And this might be the newest of all. So you can look at relative dating, and if you're lucky enough to have some volcanic rock, you could do some of this potassium argon dating. And there's many, many, many other techniques. And it isn't just about saying, oh, this skull was in this place in the world at this time. You can start to infer other things. You can look for fossils of the type of animals, the type of plants near these burial sites. You can see how dense these burial sites were. What type of cultures were there? You can start to make inferences. You can try to infer how these people died. You might have some trauma fractures here, and you might say, okay, that was a violent death. You might look at their teeth to think about the type of things they might have eaten or their general health. You might look at the tools that are buried near them. This right over here, these are Paleolithic spearheads or tools right over here. Paleolithic is defined by more of these harder edges. You have Neolithic tools, which have more of these smoother edges. The Old Stone Age, New Stone Age right over here. And by looking at all of that, you have all of these scientists, you have these anthropologists, archaeologists, paleontologists who are starting to piece together prehistory. And sometimes these techniques are done together. Sometimes we have writing and we have these techniques to try to get a more complete picture. Now, I want to end with just a note of caution. Even though we have all of these techniques and we're learning more every day, our understanding of all that has happened is very, very incomplete. And even more, it constantly gets challenged the more we learn. There are things that very serious people believed 50 or 100 years ago that we have now proven to be false. And things that we now take very seriously, it's likely that in 50 or 100 years, people might prove some of that wrong. So history, even though it's about the past, it is constantly evolving. We're constantly learning more. And we should have a very solid humility about what we know and what we don't know.